So good afternoon, everybody. Good. Good morning, everybody. This is Mike Ungar. Welcome to our Fireside chat this morning. We're really excited to spend the next hour speaking with Mike Nager. Mike, I probably misspoke your last name. How do you say it?
Well, we say it two different ways. In the U.S., we usually pronounce it with a hard A, so it's Nager, and then in Germany we say Nager. So,
and what's your preference today?
Nager's fine. It rhymes with lager. It's easy.
There you go. And everybody likes a good beer. Sure. Anyway, so we're really great to speak today with Mike Nager. Mike works for Festo, didactic, and we'll talk more about his background in a minute. So this is the Industry 4.0 Club. This is our weekly fireside chat. We come together every Wednesday at 11:30 a.m. Eastern time with a guest to kind of highlight their work and their background and what they're doing in the space of Industry 4.0. Our club hosts rooms on Clubhouse and on LinkedIn Live, Twitter, and YouTube. Mondays, Women in Manufacturing at 12:30 Eastern. Tuesdays, we speak about the future of manufacturing, something technical that of interest to our club. Wednesdays, Fireside Chat. And Thursdays, we speak about people, culture, and process at 12:30 p.m. as well. So we're excited to have Mike with us today. We also, maybe before you introduce yourself, I'll let our co-hosts introduce themselves today. Carol, you want to start, and then we'll let Nikunj go.
Sure, thanks, Mike. I'm Carol Michelin. I'm an Industry 4.0 Club co-founder. I'm a co-host of the Women in Manufacturing Room on Mondays with Grace Donovan. And when I'm not on Industry 4.0, I'm a content marketing specialist with Raven AI. Thanks, Mike.
Thanks, Carol. Welcome, Nikunj. Nikunj, you're on mute.
Yes. Hi, good morning. Good to be back here on this Fireside Chat, and welcome, Mike Nager. I'm looking forward to hearing a lot of your insights from smart manufacturing. And I'm the founder and CEO of Falconry. I'm also a co-founder of the Industry 4.0 Club and a sometimes presence on the Industry Fireside Chat. So I'm glad to be back here today.
Thanks, Nikunj. And just for the audience's benefit, so I retired from Michelin North America about 20 months ago after 35 years working in manufacturing and continuous improvement operations, HR, and finance. Today, I'm a business coach and executive coach and also a co-founder of Industry 4.0 Club. So, Mike, welcome. We're excited to spend the next hour with you. Mike, tell us a little bit about your background, if you don't mind, and maybe a little bit about what you do today.
Okay. Thank you, Mike, and thanks for the invitation to talk here. I appreciate that greatly. So my name is Mike Nager, and I work currently for Festo Didactic, but I am an electrical engineer by education. I went to the University of Scranton. So Scranton's become popular afterwards because that's where the Office sitcom show was filmed. A lot of people know it for that. And when I graduated as an electrical engineer, my very first job out of college was working for a manufacturer of industrial controls outside of Philadelphia. And I got the job writing operator manuals for what was new technology at that time, which was electronic PID controllers, so proportional integral derivative controllers, and it was just moving to electronics at that point. So I probably dated myself a little bit. I shouldn't do that, but there was a need to write the documentation for this. Prior to that, a lot of that control was done pneumatically. And that was kind of interesting to learn, because that's nothing that I had learned about in school. So the field of industrial controls, I kind of stayed in, ever since I graduated. I've worked for several companies that manufacture industrial controls and process controls. And just, coincidentally, a lot of those companies, the majority of them have been based in Germany. So for the last 20 years, in one way or another, my task has been to bring German technology into the US market and find the right marketing and sales and application message to put around these types of products. And, it's sensors, it's controllers, it's transmitters, it's all the devices that are used in every other manufacturing and utility application that there is. So I've always worked for a manufacturer, but a very special type of manufacturer whose products primarily go to other types of machinery or manufacturing operations. So over the last 20 years, we saw a lot of automation and control, more autonomous types of systems, things that are easier to implement. And in retrospect, we were creeping towards this idea of Industry 4.0 and smart manufacturing, but just one little piece at a time. So, Mike, we were talking earlier about, wireless systems. So, when the bandwidths opened up and the federal government, allowed more use of radio signals to be used in industrial controls, that really was a game changer, because it eliminated a lot of cost associated with wiring different devices together. Every foot or meter of wire is very, very expensive when you look at the entire installed cost of that system. So, and this was 20 years ago.
Right.
We just didn't have the Industry 4.0 nomenclature to describe what we were kind of moving towards at that time.
And Mike, what are some of the milestones that you've seen in this evolution towards Industry 4.0, at least as what we call it today?
Well, the biggest one I alluded to a little bit with that first job that I had right out of college, and it was electronics. So electronics coming in to the manufacturing floor in the form of different devices, controllers and sensors. That was huge. Prior to that, there was mechanical systems or pneumatic systems that were used to communicate signals and to perform pretty sophisticated control algorithms, but not on the electronic form factor. So that was the first big one. The one more recently, and it has been very, very pervasive, is all the IT technologies that have been developed over the last 10, 15, or 20 years that are finding their way more and more into the manufacturing floor. So, something right now that we just kind of take for granted, industrial Ethernet. There was a time where people were saying Ethernet would have no place on a factory floor or in a utility, much like wireless. When wireless came out, people were saying there's no place for that. And there's, 27 great reasons why it's a stupid idea to have that technology. And then as soon as, someone like me says that, about a year later, it's spread everywhere, and there's a lot of great reasons to do it. So in my viewpoint, those are the kind of the prime movers, that IT technology coming in and really changing everything, because now you're introducing a lot of capability, but also a lot of different types of requirements from a skill set, from a talent perspective, from a workforce perspective. So that's the main one that I see, Mike.
Thank you. So as you've evolved, what motivated you to move into the education and training field?
Yeah, so for for 20 or 25 years, I worked at a manufacturer selling to other manufacturers. I got to see a lot of different manufacturing operations. I think I tallied up that somewhere around the 500 or maybe 600 sites I've been at, from pharmaceutical to tire to automotive to chemical, you name it, these devices went everywhere. And I realized that, when you're so close to it, you don't realize that's kind of special. There's not many people that can say that in the world, being able to see it. And, I had gotten to a point in my career where, seeing the big picture, seeing how we have a skills gap, seeing how we have a lot of young people or people looking for new careers or looking for a direction. And when I found Festo Didactic, who had just opened up their headquarters nearby where I am in New Jersey, it seemed like a great opportunity to jump on that, and now to kind of give back in a way to the industry and start spreading the word amongst people that don't know about smart manufacturing, don't know about Industry 4.0, but are either a student trying to find a direction in life, and the only messages they're hearing right now is go into the medical field, be a doctor, be a nurse, or a medical practitioner, and that's great. We need tons of it. Some of my own children are following that path, and they're doing great, and they'll do good. Or no, go into the financial markets, or be into the legal system. But there's a very muted call to say, consider manufacturing, consider production as a career path inside a manufacturer. So I feel part of my calling is to spread that as an evangelist and say, you know what? There are great positions, great careers, great jobs, great salaries available in the manufacturing space. And there's a lot of different ways you can enter into this industry. You don't have to go get a 4-year degree or a master's degree to enter into it. You can do very, very well, in some cases, coming right out of high school and getting into it, and then learning as you go. So I wanted to spread this message out, and I'm fortunate to work for a company that also has this as their core belief and value system. So it matched up really well.
So, Mike, you're referring here. Sorry, I'm jumping in, Mike Ungar. You refer here to those who are just completing high school and are making a choice for where they want to go work. At a time when manufacturing skills gap is only growing all over the world, I guess this is not only a function of what people choose to do after high school. It's also a choice about what they choose to do after college. It's a choice for what they choose to do after perhaps spending 5 years in the retail industry and then deciding that it's not for them. I suspect that the gap is large enough and the national priority is verbalized often enough that probably that evangelism is needed in all of those areas. So how do you see this evolving, and what's the inflection points that we can create for people to feel that this is an area they need to be watching and perhaps experimenting with?
Yeah, so great comments and question, thank you for that. So I think I would approach it, in this way. There is now, it seems like a great a great, how should I word it, initiative to reevaluate manufacturing, especially in the United States, because one, the COVID issue, we're still struggling with the supply chain problems after 2.5 years now, right? We're coming up on 2.5 year point. I just read an article that manufacturers of garage doors are now giving 20-week lead times to their customers and to their builders. So garage doors, it's not rocket science, right? It's a door that goes on your garage and goes up and down. It's a 5-month lead time now. So So the industry itself, there's a lot of political, financial, and almost moral reasons why manufacturing is being pushed back into the US. Sometimes people call reshoring. So in the 1990s, there was a lot of offshoring, right? We were looking to reduce the cost of production, so we would move it to an area of the world that had lower labor cost and then ship everything back. And that worked great for 25 years or so. Not so great in 2022. So the first message is that manufacturing itself is going to grow and become more important in the U.S. There's also political and defense reasons why this is super important. This is only going to exacerbate the problem with workforce. So even before we had this manufacturing that's poised to grow rapidly in the US, we had a problem with, do we have enough people to fill these positions from the technician level, from the engineering level? A lot of people look like me with my hairline and my hair color. And, in the next 10 years or so, they're going to be moving out of these positions, and who's going to fill them? Concurrently, we're also witnessing on a macro view the collapse of retail. So for young people in high school or maybe right out, a lot of jobs in the US where you go work in retail or fast food or the hospitality business. In the retail sector itself, every place you go, you see a mall that's closed down now. So those opportunities aren't there. So what's taking the place? Well, supply chain management, third-party logistics, the Amazon warehouses that are popping up everywhere. And the manufacturing industry is now going to be competing not so much against the retail. Manufacturing has a very good value proposition against retail in terms of compensation and wages and growth potential in general. But we're going to be competing against Amazon, and Alibaba and all the online retailers that are going to try to bring people into the distribution centers and pay it. So that's how I see kind of the macro viewpoint. And we want to make sure that our voice is heard as manufacturers, and let people know what are the opportunities for me, for my child. If I talk to a lot of people that make policy. They are the ones that determine on the education, which educational programs are going to get funded for my district or for my school district. Is it going to be nursing? Is it going to be auto body? Is it going to be manufacturing? And if you don't have any experience with manufacturing, you might not think that is something that you should invest money into or invest talent. So part of this evangelization is not just to students and teachers and to parents, but it's to policymakers as well. And the skill sets that are needed in manufacturing are very, very valuable. So to the individual. So that's part of my overall message to folks that want to learn about smart manufacturing.
Mike, I had a question regarding sustainability. A lot of young people are making decisions for the companies they work for based on their views and approaches to sustainability, and that includes manufacturing companies as well. And my question to you is, how are you framing that, and what kind of discussions are you having in your network with young people and their decisions?
Yeah, so that's a great point. So that's something that the younger generations have been taught, right from the earliest stages, and one that has a lot of merit. So, when we talk about manufacturing, smart manufacturing, and Industry 4.0, these are all terms that are kind of synonymous in a lot of people's minds, or definitely related. I would like to make a distinction with the term Industry 4.0. This is a term that came from Germany. German companies all kind of rallied around that as a marketing term. But in my viewpoint, it's a little bit unique and separates itself from the other terms, because one of the core tenets in Industry 4.0 is the idea of making personalized and customized product individually for a customer. So a make to order type of system. And in a make to order type of system, if you can do it fast enough and you have the ability to personalize it, gives a manufacturer a tremendous advantage over companies that are making mass produced products, one size fits all, you know. And it's really not one size fits all. It's like one size misfits the least number of people, the least amount, or something like that. So there's never been a one size fits all. But almost as a byproduct of that, because we're not making to stock anymore in this paradigm, the waste that's associated with merchandise that doesn't sell actually goes to zero. And you know, it's a tremendous amount of waste in the whole value chain currently under the mass production model. I mean, if you go into any retail store and look at the clothing, for example, you'll see, you know, maybe 1,000 men's suits, you know, lined up on the racks, and 1,000, you know, dresses and blazers. How many of them actually get sold, you know, during the course of the year? And, you know, during my presentations that I give, I have some examples of different retailers, and, you know, the big retailers, household names that you might know, that waste is measured in the billions of dollars per year. You know, it's not insignificant. I give one example of a clothing manufacturer. So, you know, in the manufacturing of this clothing, you know, it circulates the globe like 3 different times. If it doesn't get sold, it makes one more trip and gets incinerated and used to generate some electricity. The cost is dispersed. It's not at the manufacturer, it's not at the consumer, but there's definitely an environmental cost to all that that's not being properly accounted for today. So when I use that example, hey, you can make a smart manufacturing system. It's so smart, so precise, and so fast that you're going to create a product for a customer that's already bought it, and not anything extra that has to be thrown out because the customer wanted blue and not black, right? And that is going to have a tremendous impact environmental wise if every industry moved that way. So I think it's a real great selling point, something we should try to push more, you know, with global warming, you know, concerns and pollution concerns and all that. You know, it's another hidden gem in the smart manufacturing puzzle that often gets lost because, you know, I've been on a million of these types of councils and stuff, and the practitioners like to get into the minutiae. Well, you know, how's that signal going to be communicated wirelessly into, you know, a mobile device, and, you know, what software links, you know, and middleware do you have to have? But you know, let's stop and look at the big picture. Go to smart manufacturing and you're going to save the planet. You know, that's pretty impressive statement.
Mike, thanks for that. It's real interesting to think about what could be there. In fact, you know, I think one of the things that links really well with where we've come from in the past in terms of lean and lean principles is this idea of, you know, really understanding what the customer wants and meeting those needs very specifically. And what you're sharing, I think, is how you blend in the principles of lean and Industry 4.0 together to really create value in the market.
Yeah, that's really well said, Mike. I mean, you said in like 20 seconds what took me like 4 minutes. So.
No, I really appreciate that. Carol, did you want to continue along what you were talking about earlier? Another question along those lines or something else?
No, I don't have a question, but Mike, maybe if you could comment. It sounds like what you're doing is you're connecting the manufacturing to the marketing approach of hyper personalization.
Yeah. So that's certainly what I try to do on my day-to-day business. So I didn't describe exactly what I do. So this might be a good point to tell you. So I work for Festo Didactic. A lot of people in the automation world know Festo as one of the world leading suppliers of very high quality pneumatic and electronic controls that are used in every manufacturing industry around the world. It's probably hard to find a factory somewhere that doesn't have a Festo product in it. But I worked for the division called Didactic. Didactic mission statement is not to necessarily go to manufacturers, but to go to high schools, community colleges, and universities, talk to the people usually in the engineering departments about what their program is intended for technicians and engineers primarily coming out of it. And then because we are a German-based company, we really follow the philosophy that hands-on learning is really necessary to get a deep understanding of the subject matter. So what I do on a daily basis is talk to these professors, find out what their program is intended for the students to learn. And then I help them design an equipment set, a learning factory, a smart factory that they can place into their classroom. And the students now don't have to just learn the theoretical aspects of smart manufacturing. They actually have a running system inside the classroom. And that can include robots, that includes PLCs, that includes CNC and 3D printers. We bring in augmented reality, MES software. It's a self-contained factory inside the classroom that students will learn their trade and their craft on. So that's what I do, as my job. And this is when I'm talking to these, educational facilities, all these issues are coming up. Well, why is smart manufacturing important? What might be the driving force from the board of directors at a company to move in a certain direction? And to your point, Carol, maybe it's sustainability. Maybe the company thinks they could do a better job with sustainability than they have in the past, and it's being reflected in the stock price, and they want to make it a priority. So that I'm trying to connect the dots at that level.
Yeah, Mike, question for you. So in 2014, maybe 2015, in order to demonstrate sort of AI and smart manufacturing, we had a similar challenge. People understand by physical motion, by direct observation, as like you just said. And I remember we put together a motor generator combo and simulated things like shaft overload or bearing damage and vibration. And we showed people how vibration or stress signals could be measured, could be analyzed. AI could apply on it, find what was going on, and have a direct connection between what was happening in the physical system and what was happening in the digital twin. Because otherwise, it was kind of hard for people to grasp that. Now, that was a small system. When you talk about putting a smart factory inside of a classroom, I mean, that seems like a much more ambitious goal. My question to you is, how scalable has this approach been? What are the challenges in it? And beyond the hardware activities that you described, also the electronics that you talked about, what scope do you see for training on reliability engineering principles and on the use of industrial AI in the context of that kind of a classroom? Because we see that tends to be a very highly needed skill. Because my company works with companies in that space, we observe that people are always very keen to gain those skills. They see that as uplifting their career prospects, but more importantly, as an area where they can distinguish themselves within those organizations as those organizations seek to develop or deliver on the benefits of AI.
I see. Okay. Okay. So there was a lot in that. Let me see if I remember remember it all. If not, just chime
No, I
in and
can,
remind
of
me.
course.
So,
Yeah, I can remind.
um, first of all, the systems that we design are very modular in nature. So what we do, we to get into a little bit of a nitty gritty, we have a conveyor belt that moves the workpiece or the product in our learning factory all around to the different stations. And we don't pick a typical 24-inch wide conveyor that you would see in a distribution center. We're doing like a 4-inch conveyor that you would see, in electronics or pharmaceutical manufacturing. So we have a narrow conveyor belt that the workpiece runs around on. Each of the stations that conveyor sits upon is modular in nature. And, just to give you an idea, it's about 4 feet or 1.2 meters in length, each one of these modules, and they can all fit together. So we can scale that system very, very easily, depending on the square the square footage or the area that we have to work with, or sometimes the configuration. Sometimes we have a room that's like very long and skinny as opposed to being square shaped, so we can juggle those things around. If we're working with CNC machines, sometimes they're a little bit bigger, so we're a little more space a constraint with that. In the education sector, one of the major issues is the source of funding. So that's what's a little bit different between education and industry. So in industry, which I worked in for 20 plus years, often the sales pitch or process is some sort of an ROI type of calculation. Hey, if you use this technology in this process, your ROI is going to be, 4.5 months. And, no one ever says it, but basically, you're saying, if you're really smart, you would use this because in 4.5 months, you're going to start making money. And if you don't, then, then you don't. Well, that doesn't work in education because it's not based on an ROI. It's based on how do you receive funding sources from either the federal government, the state government, or local initiatives with local manufacturers, and that's the three primary sources of funding that comes in. So you have to be like cognizant of that. A 100-page grant application has to be written around this in order to have the funding approved. So that's the biggest challenge if you were to come from industry, which I think most of the people on here probably are. If you go from industry into education, you have to understand that dynamic. You can't just have an ROI argument. It doesn't work. Believe me, I tried it. It doesn't work. So,
I think it's a question of. Sorry, go ahead, Mike.
No, go ahead. I was going to jump into your next point. So.
Yeah, I agree with you. I think in education, it is actually about learning opportunity, not about the return that you might create. And that learning opportunity, it actually requires physical behaviors to be either simulated or injected. And that way, there can be a connection between what happened in the physical world and what happens perhaps in the smart manufacturing context. Like, how do we react when that happens? So that is the part of my question I was also trying to understand is if smart manufacturing goes beyond the industrial sort of automation that took place in Industry 3.0. So when you think about that in Industry 4.0, what are sort of those advanced things in the classroom that you've seen be either successful or well received?
Yeah. Okay. So thanks. That's a great leading question. That question that I love to answer. So, part of our philosophy is we're trying to eliminate as much on-the-job training as possible, right? So, we want students going out and of course, once they're coming from anywhere, high school, community college, university, and they get into their first position, there's going to be a lot of on-the-job training that they didn't have in the education system, but we want to try to minimize that as much as possible. So the first time they work with a programmable logic controller shouldn't be, on the second day on the job, that they landed. They should have some experience with that. And we're at a little bit of an inflection point right now because these IT and software technologies are advancing so rapidly that manufacturers, all right, maybe the big manufacturers, the top 10 or top 100 in the world, or there's lighthouse installations and they're already on top of everything. But most companies are not that. The small and medium-sized enterprises have no clue. I shouldn't say that. Are less versed on how am I going to apply artificial intelligence into my manufacturing operation. Oh, I have this thing called industrial Ethernet on the plant floor that for the last 10 years, everyone's been hooking up Ethernet cables to. And we have now just created a new attack surface for hackers and for people that are trying to get ransomware into the company. And we got to figure out how to protect that system on the plant floor, because the IT people normally are like, just all you OT operational people, just do whatever you want, just don't bother us and don't connect to our mainframe, and we'll just ignore what happens. So there's a great opportunity in the classroom for students to learn, how do I apply artificial intelligence in a manufacturing operation? And we have equipment and curriculum built around that. How can I protect my plant floor sensors and programmable logic controllers, or PLCs, from hackers getting in? We have equipment and curriculum built around that. How do I apply augmented reality in let's say a maintenance technician job title? Guess what? We have equipment and curriculum built around that. So the students, when they leave, not only have eliminated some of that on-the-job training, they might be able to go to their employer and be like, oh, when I was a senior in school, I did this to protect the network, in the learning factory. I think we better do something here, because from what I see, there's zero protection going on right now. So, let's get to it. So, if a 22-year-old could come out and make that kind of an impact on their with their employer, that would probably bode well for their career overall, I would say.
Yeah, very true. I mean, I think this is how many technologies have been adopted, whether it is, for example, the Linux operating system, or programming techniques that led to the development of the World Wide Web. Like, they all came from being experimented in the lab, being taught to students at a college, and then being adopted by their employers as soon as they left the educational environment. I think my only ask is, you've taken a lot of advanced topics like augmented reality, like industrial automation. Perhaps it's not as advanced, maybe, because it's been around for a little bit. I do think that we need to go beyond, because one of the biggest challenges we are seeing for the smart manufacturing is the use of data, and people are creating, in large companies, big silos to store all of that data, and it's rotting. On the other hand, there are very, very few people who understand how to work with data as part of their job, not as their main job. And so there's both continued education, but also the ability to churn out students, undergraduates in particular, who are able to bring together the digital learning that they have undergone with the physical learning that they have undertaken, and do so in a, as you say, in an experiential environment, like the German approach to learning goes. So thanks for those answers, Mike. Back to you.
Yeah, and the big data is a great point. So oftentimes when we work with our customers, we join into different types of partnerships. So I'm working right now on an active project with West Virginia University, and they have an R&D project underway right now on how to analyze in the manufacturing environment these big data sets that our learning factory is providing. So our learning factory is providing all these different data sets on energy consumption, productivity, you name it, whatever metrics a regular factory generates. our learning factory is generating this, but their R&D program is to, well, how now do we glean insights to this big data to improve something? So to improve energy efficiency, for example, to get back to sustainability.
Right.
That's one big thing.
Yeah, no, I think you're exactly on the right track. And in fact, lately there have been a number of reports, including by some of the leading sort of authorities on AI, that when it comes to manufacturing, it's not actually about big data. It's about good data. And there are a lot of challenges to that as well. Sorry, I'm perhaps dragging a lot here about AI and data, but I think it's important to realize that we don't have to replicate practices that, say, marketers and advertisers have followed because their world is digital. We have to figure out what is appropriate for the analog world, which is the world of manufacturing. And in that world, many people have come to the conclusion that it's not about how much data you have, it's about how well can you exploit whatever data you have. And in the examples that you're taking, I think it's perfect for people to be able to understand, how do you improve energy efficiency, how do you improve part quality, how do you improve the schedulability of the different jobs that you're trying to run. Like, these are all important topics in the context of smart manufacturing, and learning how to sort of make decisions that are a system level decision, not just about hardware or the materials or the software, but all of them taken together. Like, it is, I know it is very challenging for undergraduate students to do that, but that is the future. And we need those leaders who can teach us how to do it right.
Yeah, no, excellent points. I would say there's still a lot of low-hanging fruit out there to improve efficiencies and productivity. Everyone thinks, about the biggest, most sophisticated manufacturers that are already at 99.99, percent, but most places aren't at that level. And there's a lot of low-hanging fruit out there, and these new technologies sometimes, provide a fast and easy way of grabbing that. Maybe it would be a 5 or 10%, increase or decrease in something that's important, which is huge, right? And all these technologies play a role in allowing that to happen, if it can be done in the proper way, in the safe way, in the environmentally sustainable way, in the cybersecurity perspective way. A lot of opportunity out there to improve.
Mike, if you've done a lot of installations, if you will, or of education and training throughout the world, I'm assuming, have you come across what I would say is a couple of best practices for those universities and educational institutions that want to pursue this, that you would say, hey, if you're going to spend the money, you should do these couple of things?
Yeah, that's a great point, Mike. So, you are correct. We have customers all over the world. We believe that we are the largest player kind of in this niche industry of technical education and manufacturing. So we have installations all over the US and Canada, very heavily represented in Europe and also in Asia. I would say that there's two main things that make some programs more successful than other ones. And the first one is having a very tight industry education alliance locally. So if that educational institution has a strong input and kind of skin in the game from the local industry, that local industry to help provide them, A, with funding, for their programs, B, to provide them career and job opportunities for their graduates, 3, to help them decide which of these emerging technologies is most important to them. That'll help number 1 and number 2. And help that university or college develop their program to be extremely relevant regionally and locally. So that's the number 1 success factor. If I go in and I see there's a board of directors that's interested in my cyber physical factory, my learning factory, and there's people from manufacturers there that are listening to me to let the educators know, yes, this is all making sense, or no, this seems to be, kind of fluffy and not real, then I know that that institution's on the right track. So that involvement with industry is very, very important. And then internally within the school, there's different levels of people that have to interface with the equipment and with the students. And when we find out, in the best scenario, let's talk about a 4-year institution. Let's say a 4-year institution is running a program in their industrial engineering department, for example. We'll have the professors, 1, 2, 3, 4 professors that are pushing the R&D aspect of smart manufacturing. They have a specialty in big data or in, one of the other disciplines that they want to push the R&D. But then they also have a very strong instructor and network and technician network that are very hands-on people that keep the equipment running, can answer the students' little questions. Hey, how do I turn this on and off? How do I, calibrate this sensor? The professors generally don't want to do that level of instruction, right? They want their graduate students or their lab techs to be able to do that. So if we see great industry involvement and we see a great infrastructure within the school to support that whole hands-on learning experience, because everything has to be running in order for this thing to work. Then we know that it's going to be a great program. And fortunately, most of the places that I work with have those two pieces in place. So we're fortunate in that regard.
Yeah. Thank you for sharing that. I just want to take a moment. We're about 3/4 of the hour into our conversation with Mike Ungar, who works for Festo Didactic. And want to encourage anybody who's listening today to please feel free to drop a question into our LinkedIn Live, and we'll be glad to share that and ask that of Mike. He's been very open and willing to really address anything we've got for him today. So thanks, Mike, for that so far. But just want to encourage everybody to join us in the conversation. This is the Industry 4.0 Club, and this is part of our Fireside chat that we have every Wednesday from 11:30 to 12:30 Eastern time. So, Carol, I know we were talking in advance. You downloaded the ebook that Mike had made available. Could you share a little bit more about what you saw on that? Maybe engage with Mike on that question about that book?
Yes, of course, Mike. And thanks, Mike, for sharing that ebook in February for us at no cost. At first glance, I was impressed with the approach to creating a message that bridges the gap from people who are knowledgeable about Industry 4.0 to maybe a younger audience that is learning about it. I especially like the approach where you're including examples of pop culture in there. It makes it a lot easier to take maybe something which is presented abstractly and creating a kind of like an anchor for people to help learn. I think that was a really good approach, and I was wondering where that inspiration came from.
Thanks, Carol. So those that don't follow me on LinkedIn, please do so. What Carol was alluding to is I took the book that I published last January. It's come up on a year now, called The Smart Student's Guide to Smart Manufacturing. And because February in the United States is the official Career and Technical Education Month, I gave a link for the ebook to be able to be downloaded for free. So if you have a student, a teacher, a counselor, someone that you think needs to be introduced to what smart manufacturing is, they can download the ebook for free this month in honor of Career and Technical Education Month. So the inspiration for that is, and I'm I started this off saying I'm an engineer. I went to the University of Scranton. I'm not a writer. I'm definitely not a novelist. But so what I learned is, when I wanted to get these thoughts down on paper, I looked up how to write a book, and the very first, rule of writing a book is you have to know who your audience is. So in my mind, I had to kind of picture, maybe a 16-year-old person in my mind that this book was intended for. And the subject matter, if you're not careful, can be a little bit dry if you don't have amusing stories or anecdotes about it. And then it just kind of clicked on me that we could use movies as an example. So there's several science fiction type movies especially that really touched on stuff that are no longer really science fiction. So one that's sticking out in my mind is The Minority Report. And I think it was Tom Cruise that starred in it. So it was a big blockbuster film, but they really had a lot of technologies featured there that have become a reality today. So I don't know if you remember that movie, but in one scene he was running through a retail establishment, and the advertisements for the products were kind of following him because it recognized him. But we experience that every day now. If you have Facebook running and mention something, a second later an ad pops up for that something. So we're already there, and there's a whole bunch of books and movies that have forecast this technology, and that's becoming apparent today. So I thought it would be interesting to bring that out. And maybe if I ever do a second version, I'll expand a little bit more on that, and maybe make it well, what could have been done in this situation that would have changed the outcome? How could we make the artificial intelligence not become self-aware and take over the world? Something of that nature. Making it more of a learning experience. So jump on there. I put the link on. The link is on my LinkedIn page, so you can grab that, and then you can get this in ebook form to whoever you think might be interested in it. So,
Mike, just wanted to add before Carol really quick. So we have a comment through LinkedIn Live from Chris. Chris mentions he can speak to your comment. He mentions that ROIs have been the primary factor that has stopped technology projects from moving forward. I've only been partially successful in selling projects that don't meet a 2.5-year return. I can also say small businesses have no clue what smart manufacturing is. So interesting comment from Chris.
Yeah. I appreciate it. The small and medium-sized businesses, I mean, they really are the backbone of our country. If you look at total employment, it is small and medium-sized businesses. So anything we can do to help that area is going to be well received. And I like to think that graduates that come out of programs of schools that have used my equipment set, are poised a little bit better to help those manufacturers be more successful. At least that's what I'd like to think.
Thanks, Mike. No, that's great. No, I appreciate those best practices earlier as well. The guide, what has been the reaction to the guide? You've had it out there for about a year. What has surprised you that people have said, have gotten the most from, if you will?
Yeah. So it's been kind of an interesting experience for me. It's the first time that I've ever done anything like that. So in general, I would say I've gotten pretty good reviews on it. I have it posted on Amazon. That's kind of like the main area where you see most things. Evidently, a few people did not enjoy it as much as I did, so they marked that down. But other than that, most of the people that I've talked to seem like they enjoy it. Different people have come up to me that are not in the field and said that they didn't think they would be able to understand what something like smart manufacturing was about, but they were quite surprised to see that it was demystified and conceptually easier to understand. Okay, the nitty-gritty of connecting all these things together is really complicated, and that's why we have experts and universities to teach people how to do that. But the overall concept is not super difficult if you don't want to make it super difficult. So So I appreciate that portion of it, but right now, Stephen King can rest easy. I'm not approaching his sales levels quite yet, so I'm not going to bounce him off the charts anytime soon. It doesn't look like. So.
I have another question, Mike. A lot of initiatives are two-stream. They're focus one on the students and how they can help students. And another one is the teachers and educators and how they can help educators. I'm wondering if you have that as well in your approach.
Yeah, definitely. So, part of our approach is we have to make things look exciting enough and aesthetically, I don't have any photos to show you. It probably wouldn't be appropriate anyway, but aesthetically, we have top-notch looking equipment. So it's polished and brushed metal. It's smoked glass control panels. We're not hiding anything behind it. So from the students that look at it, some of them, right off the bat are like, yes, I never knew it, but that's something that I want to work on. And you're telling me that if I come to this school, I'm going to be working on that, sign me up. So getting students into the program and helping schools get students into that manufacturing program and not into auto body or not into nursing or not into something else is a big benefit for that program. And then it's a very astute question because these are sophisticated systems. So a lot of my effort is on train the trainer and train the instructor. So there's teaching assistants and there's lab technicians that have the duty of being the hands-on person in the lab. We do extensive training with them so that they understand how the control architecture, we have a sophisticated control architecture in this learning factory. They have to learn from the MES level all the way down to the field bus level. And we help them if they're not familiar with that, because everyone's coming from a different background. It's not a given that they're control experts by any means, but we provide that train the trainer program so that they're the most effective instructors that they can be with the equipment. So it's definitely a two-pronged approach. So it was a very astute question, whoever asked that.
Thanks, Carol. Thanks, Mike. So we're reaching the bottom of the hour. We've had a really great conversation this last hour, speaking with Mike Nager about really lots of different things, starting with the conversation around the evolution of Industry 4.0, getting into his experience in with Festo Didactic in terms of helping to educate the world on Industry 4.0 and technology. And then looking at his recent ebook and some of the things that have been helpful about that. So as we reach the bottom of the hour, maybe it's a good chance for us to kind of do some last thoughts. And I will maybe Carol, any reactions to the hour that you'd like to share with the group before we work our way through to Nikunj and myself and Mike?
Just a quick note, Mike, thanks very much for being with us today. I'm very intrigued by your smart factory in a box that you're bringing to universities for experience, I guess, in a box. Mm-hmm. I'm really fascinated by that, and I wish you the great success. Thank you.
Okay. Thanks, Carol. I appreciate that.
Thanks, Carol. Mike, Nikunj, would you like to share any last thoughts as we finish up the hour today?
Yeah, no, I know that education, pedagogy, and the physical world are a challenge for everybody. One of my good friends is the director of Advanced Manufacturing, Center for Advanced Manufacturing at USC. And he tells me that the last 2 years have been brutally difficult for him, given the pandemic and all of the physical access restrictions. Yet, there is no way to work around it. Physical access, physical systems are the bedrock for manufacturing. And so I hope that that we are able to overcome some of those setbacks in the recent past and get back on track with improving manufacturing practices and equipping more people to be ready for smart manufacturing. And thanks for sharing your thoughts today with us, Mike.
Yeah, definitely. That's the goal. That is the goal.
So, Mike, let me pass it to you. Just want to say to share any parting shots then before we wrap up the session this morning or this afternoon now.
Yeah, I'll just say, I truly believe that manufacturing is a great field for people to get into. Some people have asked me, what is that poster behind you, Mike? My dad was looking through a book on the history of Philadelphia and turned randomly to a page and saw my grandfather working here. That's him in the tie. That was at a television manufacturing plant located in Center City, Philadelphia. So at one point, we had a very strong and robust manufacturing sector, even down into the inner city, Center City locations. And there's no reason why that can't be, in the future as well. So, I'm just happy to be part of it and to help spread that message and to revitalize this whole industry, primarily at the skills and education level. So,
thank you, Mike. I really appreciate you taking the time out of your busy schedule to talk to us about what you do and about Industry 4.0. It's been really interesting, and I've learned a lot in the last hour. So just to kind of wrap us up, then, this is the Industry 4.0 Club. This has been our fireside chat today with Mike Ungar from Festo Didactic. Please join us for our other broadcasts. On Monday, we do Women in Manufacturing at 12:30 p.m. Eastern, either on Clubhouse or on LinkedIn Live. Tuesdays, the Future of Manufacturing at 12:30 Eastern, and Thursdays are People, Process, and Culture, also at 12:30 Eastern. You could find us on LinkedIn on the Industry 4.0 Club. You can also find us at industry4.0club.com. So I really appreciate, Mike, your time, and want to wish everybody a great day. Thanks for
okay. Thank you very much.
Join us. Thank you.
Yep. Thanks for the invitation. I appreciate it. Bye-bye.
Bye-bye.
Thank you.